Hi, my name is Kevin Martin. I'm a senior strategic account executive at Temporal Technologies, and today I'm going to be talking to you about orchestrating ambient agents with Temporal. I was fortunate enough to attend the AI World Fair this year in San Francisco earlier in the year, and while there, I attended a breakout session that was hosted by Amazon and Anthropic. Uh, During that breakout session, I learned about something called proactive AI and ambient intelligence, and essentially what Anthropic was positing is that we're in this era of reactive AI now, where a lot of the agentic interfaces that people are interacting with today are very much like a chat window where you send a ping, you get a pong, and that's kind of the whole thing. Their idea of the future is going to be multiple agents running asynchronously, running continuously, and then letting human beings know, status updates or maybe doing, human in the loop type of approvals. uh, I thought it was a really interesting prospect, and I can definitely see the world going that way. But to actually get there and to run multiple agents in parallel in a coordinated effort against one task, you're going to need some powerful orchestration technology. And I think that's where Temporal lends itself really well. So after the World Fair, I went to ChatGPT as one does, and I basically asked, what would be some kind of cool example use cases for orchestrating ambient agents and for some type of proactive, always-on type of use case. And one of the things that it proposed to me was like a crypto market exchange. So I decided to take that idea and run with it. So why crypto? Well, crypto markets never sleep, right? Unlike the traditional stock market, which closes on the weekends, these crypto markets are always on. So I needed a proactive 24/7 AI trading system in a durable way to keep it alive and orchestrate all of those agents. So Temporal was really a great fit here. We see people in the market leveraging Temporal for orchestrating the agents themselves, writing durable MCP tools by leveraging temporal primitives like signals and queries and what have you, doing inferencing by reaching out to the LLM and making that call hard by wrapping it in activity, and of course, RAG use cases as well. So we see teams choosing Temporal for its high scale and reliability, the fact that we have a idiomatic SDK in 6 different languages, end-to-end observability and testing, cross-system connection with Nexus, and support for non-AI use cases as well. So it's really easy to kind of, take an existing classical, more classic temporal deployment and tie in some agentic use cases into it. So how did I build this system? There's really three core agents at play. The first is going to be the broker agent. The broker is basically the interface into the system. It's the only agent that the human being is going to interact with. It's going to be responsible for determining the overall skill level of the human user and which crypto pairs to track. It'll also be there for the human being when they want to inquire as to like what's the portfolio status or what's the transaction history, what's the profit and loss, so on and so forth. But the real work is going to be done by the execution agent. The execution agent is a completely agentic, no human being involved agent that's going to be responsible for basically doing the buys and the sells or the holding. It's going to evaluate the portfolio status and current market data and decide whether or not it thinks, it should be doing anything in terms of like market transactions. And finally, we have a judge agent. The judge is going to be basically an implementation of a pattern called LLM as judge, where over time it'll quantitatively analyze the performance of the execution agent. And based on the output of that score, it'll determine whether or not it needs to actually update the system prompt of the execution agent. So this way, the system is always kind of learning from its performance and hopefully getting better over time. So how are we leveraging temporal here in action? There's a bunch of primitives that are kind of in play. The first one I want to talk about is schedules. So with these proactive systems, you need some sort of thing that's going to keep the system running regularly in particular, usually some sort of time-based thing, right? Um, I like to think of the LLMs as kind of the brain of these proactive agentic systems, but I really do believe that temporal schedules are the heart. They are a fantastic way of durably making sure that things happen on time. So in our system here, we have a nudge schedule that's actually going to effectively nudge the execution agent every 25 seconds to do its market analysis, do its portfolio analysis, and decide whether or not to buy, sell, or hold with respect to its cryptocurrency holdings. The schedules are durable, they're automatic, they're malleable. If you want to change the time period of a running schedule, it's really easy to do that inside of the Temporal UI. So they're incredibly flexible and a huge step up from cron. Signals and queries are used everywhere in this demo. It's a fantastic way to basically allow agents to communicate with one another. For example, when the judge agent runs its performance analysis, it's actually able to signal in the new system prompt to the execution agent. And before doing so, it can actually query the execution agent for its current system prompt so that it knows what the starting point is and what edits it wants to make. That's just one example, but these signals and queries are everywhere throughout the system. We'll be sure to show that during the demo itself. The UI has been amazing to develop this with. You get a timeline for every workflow, every action, every signal, every query. You get a great way of seeing exactly how things flow through the system. And you can answer some really powerful questions like, did the execution agent get nudged? Did the judge agent update the execution agent's system prompt? And of course, for a trading system, it's great to have a built-in audit trail. And with everything represented as a timeline, it's really easy to kind of get that for free, which is awesome. We leverage workflows for agent orchestration. So we follow the entity pattern where each of the agents has a dedicated workflow that represents basically the agent itself over its life cycle. For example, the execution agent will be logging all of its decisions to its own workflow, and you'll be able to see the calls out for placing an order and what was the rationale behind doing so, and so on and so forth. The workflows are obviously fault tolerant, and a lot of people kind of get confused with workflows and AI. They think, oh, a workflow is like a predefined code path, which means there's no real room for inserting anything probabilistic like a call out to an LLM. That is a misconception. I want to be really clear that your workflow has to be deterministic so that you can replay, so that you have the durability, but you can wrap anything that isn't deterministic inside of a temporal activity, and you're going to be in fine shape. So any kind of call out to an LLM can just be wrapped in a temporal activity, and you can have that probabilistic nature. You can mix your cocktail of determinism and probabilistic, use cases. So it's really a powerful abstraction. This one is probably nearest and dearest to my heart. It's going to be temporal primitives for MCP tools. So we have a whole slew of tools that are exposed via our MCP server, one for placing orders, one for getting the portfolio status, one for starting the market streams, and so on and so forth. All of these are temporal primitives. So whether, get portfolio status, that's a query, right? Sending user feedback, that's a signal. Starting the market stream, that's actually going to kick off a workflow. But this makes every single tool exposed by our MCP server, which is effectively like a toolbox for agents, and make sure that all of these tools are durable by default. And finally, we've implemented a system for feedback, which allows us to, let the human being kind of chime in whenever, while these agentic loops are running, and provide feedback. The agents are going to queue and process this feedback asynchronously, so there's never going to be an impact to there's no like stop or pause or interrupt happening here. When we want to give feedback, we can just kind of chime in whenever, and as the agent wakes up and goes through its loop on the next time, it'll make sure that it processes any feedback that was sent in between loops. So without further ado, I think we should jump into the demo. So I'm going to go ahead and run the system, and you can see we've opened up 7 panes in Tmux. The top left is our temporal server, the top middle is our MCP server, the top right is our temporal worker, and the 3 in the middle are the interesting bits. So I'm gonna open up those windows a little bit bigger. In the left here, output in pink, that's coming from the broker agent. And so the broker is basically saying, hey, I'm here to help you pick out your Coinbase, pairs. Can you tell me a little bit about your experience level, your risk tolerance, and your trading style? In the middle, we have our execution agent, which is currently waiting for the market streams to start. And over there on the right, we have the judge agent who's sleeping until the system's been running for long enough for it to do a quantitative analysis of its performance. So the first thing I'm going to do here is I'm going to specify my experience level, my risk tolerance, and my trading style. I'm going to say advanced. I'm going to say my risk tolerance is high and that my trading style is aggressive. Let's have some fun. And so I'm going to go ahead and give it my response. And what it should do is it should take this data and call the set user preferences tool, which we can see has now happened in yellow. Over here, the execution agent has acknowledged that the user preferences have been updated. And over here, the judge agent is now going to go ahead and take those user preferences, and it's actually going to go ahead and um, rewrite the prompt of the execution agent. Let's actually go take a look at this inside of Temporal. So if we go back to the execution agent, we can see, look, here's the updated system prompt that just came in based on the user preferences. And so you can see there's the high risk aggressive trading strategies, right? That's directly from the preferences that we just set. So it's really cool to kind of see how you can have one agent as the interface into the system, but it can go ahead and use signals to actually update the multi-agent system as a whole, right? All right, let's go back to the terminal. The broker wants to know what cryptos do we want to trade. We'll say Bitcoin, Ethereum, and Doge. And we should see it now call for another tool called Start Market Stream. And so there it went. It's starting the market streams. We can see the ticker data is rolling in here in the bottom, their little ASCII ticker chart. And we can see that the active symbols have been updated by the execution agent. So at this point, the system is now running continuously. There isn't anything for me to do at this point. I can just kind of walk away and let it run. But for the sake of demonstration, I'll go ahead and show you a couple more things that we can do. So here we can see the nudge came in from our schedule, which started, once we specified the market streams. And it's going ahead and it's collecting all of the historical data. And then now that it's collected the current data, it's going to go ahead and start the analysis phase. By default, I believe the system starts with $1,000 for the portfolio in cash. All of the transactions that you're going to see are fake. They're just going to a mock ledger workflow, which allows us to kind of see a timeline of all of the purchases and then, query for transaction history, for example. But here we go. We can see right here, it placed a mock order for 3 orders. And, we can see it bought Doge, it bought Ethereum, it bought Bitcoin. And here's kind of the summary: total costs, remaining cash. So it has this, 8.8% cash buffer retained. And it says the orders were executed as market fills per instructions. So that's great. And here we go. It's on the next nudge and it's placing yet another order. It looks like it is buying some more Doge and continuing to remain aggressive with a small cash buffer. So now I can go back to the broker here and I can say, what is my portfolio status? And what the broker agent should do now is it should go ahead and run another MCP tool, get portfolio status, which is just a query into a workflow that'll go ahead and effectively grab exactly what the current status of the portfolio is. So here we go. We can see the total value of the portfolio is $999.42. It has an unrealized profit and loss of negative 58 cents because you can see the market took a little dip here in the chart. And then it's going to, go ahead and make some suggestions that you could then basically send to the execution agent. So it's great to see that the execution agent is running, but I'm a little bit concerned that it's not really reporting its reasoning when it makes action. So what I'm going to go ahead and do is I'm going to say, please pass some feedback to the execution agent. I'd like it to shortly summarize its rationale to the for each of its trading decisions. And so, I think that's good. We'll go ahead and hit send. And so now what the broker agent should do is it should go ahead and use a tool called send user feedback. And so here we can see the tool got called send user feedback. And it says feedback sent to the execution agent acknowledged. I've asked that all future execution decisions include a concise 1 to 3 sentence rationale covering objective signals, risk management, time frame, and confidence tailored to your advanced high aggressive profile. And so the execution agent right now is currently in the middle of a loop. It's doing its data analysis and it's going to make some decisions. So it hasn't seen this message yet. But the next time it loops after its current run right now, we should see a little email emoji and a little green check mark, meaning that it acknowledged the email. So it's going to go ahead and place a couple more orders. And there we go. Here we can see it processing one user feedback message, process user request, please provide a short summary, da 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 da. And now this next time that it goes ahead and it takes action, we should in fact see some rationale present in the output. So I'm going to go ahead and let this execution agent make its decisions. And while it's doing that, let's go ahead and take a quick look at the temporal UI again. So here you can see, here are all the nudges coming in. Oh, am I on the temporal UI? Whoops. Here we can see all of the, nudges coming in, all of the decisions being logged, all of the, user feedback coming in, marking the feedback as processed. Temporal's timeline just gives you a fantastic view into, the system at large and how it's running. So coming back to the terminal, here we can see we now have the objective, the primary signals, the risk management. It's now giving us rationale for each of the decisions that it's making. So you can really, pass feedback in real time to this agentic system through the broker. And it's really a great way of asynchronously adding input to the system without breaking the loops themselves. So I want to let this run for a couple more minutes so that we can see the judge agent run its LLM as judge pattern. So for now, I'm going to jump back into the temporal UI and show you some other stuff. So first and foremost, we'll go ahead into the stream. So this stream is actually the stream that's responsible for basically getting all of the stock ticker data out of Coinbase. And you can see it's basically fetching the tickers, recording the ticks, and computing the individual vectors. Obviously, this is a ton of data that's coming in at any given time. And the fact of the matter here is that obviously like a workflow history is bounded, right? So the cool thing about these workflows is that they continue as new from time to time to make sure that they don't blow out the event history. But no data is lost either. It's just a super nice continue as new, and we continue to run. So here's an example right here in the UI. You can see the original stream has already done a continue as new at least once. We can pop here into the ledger. We can see all the record fills, right? Here's everything that's been happening in the system. If we crack one of these guys open, we can see what it did. It did a buy. Here's the cost. Here's the price, et cetera, et cetera. So we have a great transaction log of all of the buys and sells that the system has been making so far. And then finally, we can go into each one of these individual streams. So this is how we kind of take that, multi crypto pair stream in from Coinbase, and we fan it out into individual features. Uh, and then is there anything else in here that I should probably show you? Let's see. I think we talked about all of these. So here in the broker agent, we can see it hasn't really done too much. It's just set the user preferences and it's set the symbols. And the execution agent is doing the majority of the lifting. So I'll go back to the terminal now. Let's see how the system is doing. I'm going to ask the broker, uh, please fetch the current portfolio status and concisely summarize the P&L. And so you can see it's gone ahead and it's requested the tool. Forget portfolio status. It's going to take the output of that tool and chew on it and give us the P&L. And it looks like we made a little bit of profit. So that's cool to see. We have a total P&L of $3.53. We've realized 20 cents in actual gains, and we have an unrealized P&L of $3.32. And there's kind of the position level unrealized. So we're seeing, how the system is kind of performing as a whole. So here we can see now, finally, the judge is starting its evaluation cycle. So it's collecting performance data, it's generating the evaluation report. The execution agent over here continues to kind of chug along. And it's going to be really interesting to see what the judge does here. So great. It overall it passed. You can see that the returns are 100 because we've been making good trades and we're in the green. Risk management 77.9, decision quality is 50, consistency is 0. So the overall score here is 62 out of 100. Anything over 50 doesn't trigger a system prompt update. So it says, look, no context updates were needed. Um, but if it ever slipped below 50 out of 100, it would go ahead and actually rewrite the system prompt like you saw it do when we set the user preferences. All right, so I'm going to go to some final takeaways here. All right, so final takeaways. These are like the most important things that I want to, kind of hammer home. Schedules keep agents proactive. They are the heartbeat for multi-agent proactive AI systems. I think they are going to be incredibly powerful and a key component for a lot of these organizations and teams out there that are trying to build multi-active, proactive, and ambient systems. Signals and queries allow for really clean coordination between agents and tools and uh, wide variety of things. But you get a fantastic log, like you saw, of everything that's happening in your agent workflows, and it's really easy to see what happened and when. And why is it easy to see what happened and when? The UI, right? We went through the UI. You got to see the timelines. You got to see how things are executing. So it's a really powerful visual indicator of how your system is performing. Reliability first and foremost, right? That's what people use Temporal for. At the end of the day, our main value prop is durability. We're a durable execution platform, so it brings this world-class operational maturity to our AI systems. Uh, Tools as primitives, right? For MCP tools, they are just these fault-tolerant building blocks. You can make every single tool a temporal primitive, and then you'd never have to worry about it being a shoddy tool or like an API failing or getting rate limited or any of that stuff. You're going to have a natural way of calling a tool and trusting that it's going to be, seen through to completion. We have patterns that are published for long running tools, and it's only going to get better from here as we continue to kind of integrate Nexus into MCP. And finally, extensibility or extendability. It's so easy to add more tools and add more agents. Initially, when I built the system, it was just the broker and the execution agent. I went to a AI meetup that was hosted by IBM, and I heard Claire Longo from OPIC speak about this idea of LLM as a judge, and I was able to throw the judge in a matter of a couple days. It was really quick for me to kind of wrap my head around it and just add another agent to the system. And I think Temporal really allows you to move fast without having to worry about breakage because of its durable execution platform. I hope you enjoyed this demo. I had a lot of fun building this. The code is open sourced on GitHub. Go and have some fun. Uh, I'm not a financial advisor. Don't put real money in this and extend it to do real trading. I don't think ChatGPT 5 is there yet. But you can go ahead and have fun and at least play with some mock money and see how you do. Cheers.